Let's talk about Kubernetes. It is the absolute engine of the modern cloud. But let's be real for a second. Running it in the real world is a whole different ballgame. It's incredibly powerful, but man, is it complex. So in this explainer, we're going to cut right through all that noise. We're going to break down everything from the huge strategic choices you have to make right at the start to the nitty-gritty of keeping it all running smoothly day in and day out. And look, this isn't just some tech hype. A 2023 survey from the Cloud Native Computing Foundation found that a whopping 66% of organizations are already running Kubernetes in production. This isn't some emerging tech anymore. It is the standard. It's the engine powering the apps you use every single day, which means understanding it is more important than ever. So what is it really? Well, at its heart, Kubernetes, or K8s as you'll hear it called, is a container orchestrator. Just imagine you have hundreds, maybe even thousands of application containers. Kubernetes is the brain that automatically figures out where to run them, how they should talk to each other, how to scale them up when traffic goes crazy, and how to heal them when something inevitably breaks. That level of automation, well, that's why it took over the world.
To really get a grip on all this, we're going to walk through 5 key areas. First, we'll survey the landscape to get the big picture. Then, we'll tackle the first huge decision every team faces, managed versus self-managed. From there, we'll dive headfirst into the security maze, explore the real-world operational challenges that pop up after you're up and running, and finally, we'll map out a path forward with some key takeaways.
So let's kick things off with Section 1, the K8s landscape. Before we get into the how, we really need to understand the why. Why did Kubernetes become so dominant? It's not just about running containers. It's about solving the massive challenge of running them reliably, at scale, across pretty much any environment, whether that's your own private data center or any public cloud you can think of. This context is absolutely key.
And that brings us right to Section 2, managed versus self-managed. Now that we get the landscape, we're at the first fundamental fork in the road for anyone starting this journey. Are you going to build and operate your own Kubernetes clusters from scratch, or are you going to pay a cloud provider to handle all that heavy lifting for you? Believe me, this one decision has huge implications for your team, your budget, and ultimately where you spend your time and energy.
And this really gets to the heart of the trade-off. Going the self-managed route gives you total control, all the flexibility in the world, but it comes with a massive operational burden. I'm talking about you managing the control plane, you patching all the components, you dealing with every bit of the underlying complexity yourself. Managed services, on the other hand, just abstract all of that away. The cloud provider handles the control plane, so your team can focus on what actually makes you money, your application.
So if you decide to go the managed route, you've got another choice to make, and it's usually between the big 3. Amazon's EKS, Microsoft's AKS, and Google's GKS. And they all compete in really interesting ways. People often say AKS is the easiest to get started with and is pretty cost-effective, especially if you're already an Azure shop. GKS, which was born out of Google's own internal systems, often leads the pack on advanced features and super powerful autoscaling. And EKS, it really shines on performance and its deep integration with the rest of the AWS universe. The right choice for you really boils down to your team's expertise and what you value most.
All right, Section 3, securing your environment. And listen, this part is completely non-negotiable. The power and flexibility of Kubernetes are a double-edged sword because, and I need you to hear this, it is not secure by default. Hardening it takes deliberate, continuous work, and in this section, we're going to figure out how to tame that beast.
And this is where the reality of Kubernetes security really hits home. The number one threat isn't some fancy zero-day exploit. It's just simple misconfiguration. One recent survey found that misconfigurations were found in a full 40% of Kubernetes environments. That's huge. After that, you've got problems like relying on insecure defaults, failing to manage your secrets properly, and a lack of network segmentation. The main takeaway here is that the biggest risks are often the ones we create ourselves.
So how do we fight back? Well, it's all about building layers of defense. First, enforce the principle of least privilege using what's called role-based access control, or RBAC. Basically, don't give any user or any service more permissions than it absolutely needs. Second, you have to scan your container images for known vulnerabilities before they ever get deployed. Third, harden your cluster against industry standards like the CIS benchmarks. Fourth, isolate your applications with network policies. And finally, please make sure your secrets are always encrypted.
But let's be honest for a second. Putting these best practices into action, it's not always so easy. This quote from a developer on Reddit just hits the nail on the head.
While RBAC is the foundation of your security, trying to manage all those permissions across dozens of users, teams, and clusters can turn into a complete nightmare of YAML files. It's powerful for sure, but it's famously difficult to manage when you start to scale. This brings us to another supercritical security layer that often gets overlooked: networking. By default, Kubernetes networking is a total free-for-all. Any pod can talk to any other pod. Now think about that. It means if one single, non-critical app gets compromised, an attacker could potentially move sideways and get access to your entire cluster. Network policies are basically the native Kubernetes firewalls that let you lock all that down, creating essential walls between your applications. Okay, so you've made your platform choice, you've started locking down security, but the work is just beginning. Let's talk about what happens next, the ongoing day-to-day challenges of running Kubernetes in production. This is what engineers call Day 2 operations. And trust me, this is where the real complexity lives.
So imagine this scene. It's 3 a.m., your pager goes off. A new version of your most critical application just went live, and suddenly error rates are through the roof. The deployment failed. What's your plan? How quickly and how reliably can you get back to a state where things were working? This isn't just some hypothetical. It's a question every single on-call engineer has to face.
This is where modern incident management can be an absolute lifesaver. Instead of a frantic manual scramble in the middle of the night, you can build an automated playbook. A monitoring alert can automatically kick off an incident. That incident can match a workflow you've already set up, which then automatically executes the kubectl rollout undo command, instantly reverting the failed deployment. This turns a high-stress, error-prone manual job into a reliable, automated recovery process.
But rollbacks are just one piece of this puzzle. Day 2 is full of these persistent headaches. How do you control your cloud spend when developers can spin up resources so easily? How do you stop your on-call team from burning out because of alert fatigue, just a constant stream of notifications that aren't even critical? How do you manage secure, temporary break-glass access for emergencies? And on top of all that, you have to keep up with the relentless pace of Kubernetes version upgrades. So we have covered a ton of ground, from high-level strategy all the way down into the weeds of operations and security. Let's bring it all together in our final section, Your Path Forward. We'll summarize the most important lessons that are going to help you succeed.
When it comes to security, this checklist right here is your foundation. 1. Always use RBAC and treat that cluster admin role like the master key to the entire kingdom. Grant it very, very sparingly. 2. Implement network policies by default to separate your applications. 3. Make vulnerability scanning a mandatory step in your build process. 4. Automate your configuration checks. And 5. Handle your secrets properly. Encrypt them, and never, ever, ever check them into your source code.
And that leaves us with a final thought to chew on. Kubernetes isn't a destination. It's a constantly evolving ecosystem. The real question isn't whether you should adopt it. For most of us, that ship has sailed. The real question is, how will you and your team adapt your skills, your tools, and your culture to truly master its complexity and really harness its incredible power?